-2, -5, 3, and 0, 1 represent a function. Now, some of you are saying, well, Ernie, that's very interesting. How can you tell? There's just a bunch of points there. I agree. So what we're going to do is we're going to put in a table, we're going to look at a graph, and we're going to also look at a mapping, and then we're going to come back and say, oh, that's why they do or they don't make a function, all right, when we see points even. So if you'll let me take this away for you a minute. We're going to put some of these things first on a graph, all right? And first thing I need to do is regroup and tell you what those points were once again. I believe we've got 4, 2. We've got -2, 2. We've got -5, 3. And 0, 1 working for us. What we're going to do, we're going to plot these on the graph. Now, these are relations right now. You say relations? Yeah. These points definitely make a relation, all right? The question is, will they be a function also as they stand alone? And there's a few little requirements, very little, but also important ones there, and they're easy to figure out when we go. Let's plot these, by the way. Everybody remember how to plot? This one's going up in first quadrant, quadrant 4. We're going to go over 4 and up 2. Got it? We're going to go -2, going to the left, and up 2. That's interesting. Those look like they're lining up, so to speak. Well, actually, any 2 points line up, by the way, folks. You knew that, right? Let's see what happens with the next one. Probably knock out everything else. So let's see. We got -5. Yeah, these kind of take us out of what we thought might be a pattern. Go up 3. And last but not least, we've got 0 and 1. Well, it looks like those were kind of heading up. Those really are just crazy looking points, aren't they? They're still a good relation, but the question is, are they a function? Now, do they have to line up to be a function? No, they don't have to line up in any certain manner. In fact, the way you tell, and I'm going to bring on my friend Curious George. Here he comes, all ready. And what we're going to do, we're going to slide him across. And as he goes across and counters a point with the ruler here, see him? There he goes. I thought I was covering him up. And every time he only encounters 1, if he were to counter 2 on this, what we call the vertical line test coming through here, that would blow the function aspect. As long as we don't have 2 points lining up, and dear friends, we do not. There's our 1, 2, 3, 4 points. They all go through one at a time. It's all about vertical. Notice some of you are saying, well, Ernie, those 2 right there, aren't they lining up, so to speak? They're in a horizontal fashion. That does not count. Again, we're looking for the vertical line test. So as you bring your ruler across, these are a function, okay? So first of all, they pass the vertical line test. You say, all right, that's cool. Yeah. All right, now, what else do you notice here? If they're going to pass the vertical line test, my friends, you have no repeats in the x values. Now, you can have a repeat in the y values. Notice we have that with the 2's, all right? But no repeats allowed in x land here. So we have no repeated x values. That's what another thing, that's what the ordered pairs actually tell you. Now, you're saying, what is this thing about a table? What are we talking about with a table? Well, a table, we're just going to say, I'm going to put it right over here. I think we've got enough room. We're going to make x, y out of this, all right? And it's another easy way to line things up when you got that. You're going to put 4 and 2. There we go. See that? There's x, y. How about it? -2, 2. -5 and 3. And there comes 0 and 1. So that's what we mean with the table. And many of you say, oh, I remember doing those kind of things when I was back in elementary and middle school, and even some in high school. You make tables and graph things. Exactly. So there's 1, 2, 3 of the deals. Now the other one we got is a little thing called a mapping. Let's see if I've got room for that. And that's where we're going to basically make some, looks like little ovals here. We'll put an X, and we're going to put a Y there. And the idea is X maps to Y, okay? So again, this is X comes before Y alphabetically. It comes the same way before X comes before Y here because of the ordered pair, all right? And in the table it does. So we're going to do it here also, all right? So let's see what happens here. We're going to put our values, our X values over here, and you know, the really rhyme or reason of it, they're all different ones, right? So we've got 4, -2, -5, and 0. Now, if you have a repeated value of X, you don't repeat it over here, all right? Because otherwise, it's not going to really help you any. So we have those 4 distinct values. Now let's go over here to the Y's. Well, we had a 2, and then we had a 3 and a 1. Now, you can put those things in order. Some of you get rather compulsive about those kind of things, and you can do that. What we're going to do is we're going to show the mappings. Here we go. And 4 goes to 2, but also -2 took us to 2 for whatever reason. We have -5 working its way over to 3, and then 0 over to 1. Now you say, well, Ernie, what's good with that? If we just saw that, could we tell if it's a function? Again, what you would have is from every x value, it's going to a distinct place in the y, okay? In other words, 4 isn't going 2 places. 4 is only going to the 2. -2 is only mapping to the 2 over here. -5 down here is only mapping to the 3. And 0 is only mapping to the 1. So it's all about, if you saw more than one arrow coming off of a number in the x mapping area, you would be blowing the function. So because there's no double arrows coming from x, we'll say, all right? Now there are arrows that get to y. 2 of them go over here to y, but that's the idea, all right? So again, we have no repeated x values, and each value of x in the mapping has one arrow coming from it, has exactly one. Heading toward y. I hope that made it inside. Whew, just barely made it on your screens, my friends. There you go. Just squeezed it in. So that's the idea. Again, remember, Curious George helps us out up here with vertical line test. That is the easy way to see it off the graph. The mapping, if you're given a mapping situation, oh my goodness, you're looking for, once again, each number has exactly one arrow coming off of it. You've got more than one arrow coming off of it, you don't have a function. That makes sense? No repeated x values. Whether you're here or in the table, the values should not repeat, okay? So, easy street, good enough, good start. Everybody good on that? The basic definition, what is a function? What is a function? Is that for every value of x, there is a unique y that it's going to go to. It's not going to go to 2 different y's. It's going to go to exactly one y. And the mapping is so beautiful the way that works. So let's see what's coming next here. Another set of points. Why not? And let's take a look at them there so you guys can write them down at home. -3, 2 is the first point. 4, 1, 2, 0, and 4, 3. We're going to check those out and see if they determine a function. Some of you may have just watched the last little segment and said, I figured this one out already, because there's an easy way to do it. Then we're going to do represented just like we did again. We're going to graph, we're going to make a table, and we're going to map, okay? So if we can take this away from me, let's go to the graphing paper, and let's put our points on here, my friends. We've got, first of all, we've got -3 and +2. Let me just write those down there while you guys are writing also. -3, 2. We get 4, 1. We've got 2, 0. And we got 4, 3. Everybody good on that? I hope I didn't mess up anything. If I did, we'll still use those points. Yeah, everything looks good. Now, some of you are already going like, Ernie, it's not a function. I said, why do you know it's not a function? Because some of you are saying, I see repeated 4s in the x thing. Absolutely. So we already know it's not a function. What we want to do is run the test for everything else, all right? So that happened right there, repeated value of x, cha-ching. That was easy, wasn't it? Let's plot it and see if the vertical line test has problems. We're going to go out 4 and up 1. That one's easy. Out 2, go nowhere. That's 2, 0. Remember, you go left and right first, and then you go up or down. So it's not here, it's down here. Be careful. And I've got one more. Out 4 and up 3. I think everybody can see how the vertical test is going to fail here, but let's bring Curious George on just for the encore, all right? Here we go. Come on, George, get it going. There we go. 1 point, that's all right. 1 point, that's all right. Oh my. See there, folks, 2 points lined up vertically. There they are. Boom, boom. Curious George says, and I say, also, all right? No, not a function because that violates the vertical line test, all right? Once again, we only want to pick up 1 point whenever we do. be a function. If we get more than one, i.e. 2, or even sometimes more than that, blows it, okay? Bad news. So there's another way we look at it. Let's look at the table. Table's going to be real easy to make, I believe, so we'll pick it up right here. And let's see what we got, our XY table. And we got a -3, 2. We got a 4 and a 1, but it's just another way of representing a relationship of points here. We can use the table. 2, 0, and 4, 3. Again, there's your repeated X. You can see that happening. And by mapping, how about it? Let's see what's going to happen. We got X and we got Y. Draw a little map bottle here. Another little bottle here. All right. And there's your X, there's your Y, and let's see what happens inside those. By the way, sometimes people put the X's and Y's inside there. It's really immaterial where you put the X and Y. It represents, so the first one, and you're going to be mapping over to this one, all right? So let's see what we have. We have a -3. We have a 4, and remember I said, if it repeats, you don't put it in there twice. You just put 1, 4 in there, and then 2. That way you're going to be able to tell, do we have this? Obviously, we're going to get 2 arrows coming from the 4, it looks like. So let's see what we got over here. We got over here 2, 1, 0, and 3. Again, you can put them in order, but I think it's just as fine going in this manner we got here. So we know -3 is going to lead to 2. That's good. 4 is going to lead to 1. That's wonderful. 2 is going to lead to 0, but here comes our problem. 4 is also going to lead us down there to 3. And remember, we can't have 2 arrows coming from that 4 going over there to find 2 different answers. 4 leads us to 1 or it leads us to 3. It can't lead to both if we have a function, all right? And that's what these arrows are saying. You start with 4, go to 1. Start with 4, go to 3. Impossible, okay? It's got to go one or the other. Can't go to both and be a function. Everybody good? It can be a relationship, but to be a function there, we cannot have that repeating value of X, or in this case, the vertical line test, or in this case, the arrows going in the wrong place. So you have it all under wrap and key there. Everybody good on that? That's your second function that we've worked with. Let's try another one here. You ready to practice? Here we go. Do the points 4, 6, -2, 5, 2 and 2, 3, 0, determine a function. And again, we're going to represent these ordered pairs as a table, a graph, and a mapping. So at home, already getting your graph plotted, and everybody good on that. This is good practice. Sometimes we forget, we get a little lazy on those X and Y axes, but just remember, that's why we're doing these things, is going back and doing reviews. Summer school, right? It's supposed to be fun and easy. So this one should be fairly straightforward. Let me pull off here and let me get my graph going while you guys are working on yours. So we got the points, 4, 6. I also see -2 and 5. I've got 2, 2. And I've got 3, 0. Again, nice fun ways to practice some graphing here. 4, 6, both are positive, so we're going to go visit quadrant 1 up here. Ooh, that's way out there, isn't it? Up 4. And there we go, up 6. There's our first point, all right? -2 and 5. So we're going back this way, and we'll go up 5. Right there it is. 2, 2. Right there we go, to the right and up 2. And then 3, 0. How about it? Go out 3, and we don't go anywhere else. To the right 3, and nowhere. Now some of you are saying, ooh, that looks kind of weird. It's just 4 points scattered, isn't it? And you start thinking, wow, we almost had an but we don't, do we? Because when Curious George comes along with his ruler, boom, there's 1, boom, 1, boom, 1. Remember the vertical line test? Satisfied. It's a function. It's also a function because we have no repeating X's. So there's your first 2 things that give you a hint. Make a table. It did say make a table, right? So let's do a table right down here. And we got our X and our Y. So how about it? 4, 6, -2 and 5, 2, 2, and 3, 0. And I want to tell you something. Most of us like to see, for some reason, when we graph things, we like to create tables versus a bunch of ordered pairs. But that's what the tables represent, okay, the ordered pairs. And again, I'm not going to go through the mapping because I think we're running short on time, but you're going to notice here, as you map x to y, what's going to happen? We'll go ahead and show you anyway, right? So here's your x, there's your y. It's actually a one-to-one correspondence is what we call it. There's 1 taking you from each of these numbers, 4, -2, 2, and 3. And that is a 4, by the way. There's the 6. And you got a 5, a 2, and the 0. And notice you have 1 across, 1 across here, 1 across there, 1 across here, and we can take that all the way over to the 5. There we go. And the idea is for everyone here, there's 1 over here. That's why it's what we call a one-to-one correspondence. So you have it. Very much so. Function, function, function on all counts. There you have it, all right? And everybody good on those? How do we know? Because for every value of x, there is a unique, only one value that it can map to y with. That sounds like a good way to talk about it, right? Functions, you got it, all right? Now, you say, Ernie, that's nice. So do we ever use functions in real life? Well, let's take a look at this problem. It says the rates for parking are $2 for the first hour and $1 more per additional hour, up to a $7 maximum. Now, if you go park in the garages downtown or in different places, some places you get to park for free. But there are a lot of other places where you're going to pay to get in there. And that first hour, they pay a little extra, and then they just tack you on with a little bit more. Sometimes it's per additional half hour, but usually there's going to be a maximum in there somewhere, all right? They're not going to make you be charged forever and ever and ever, all right? So let's see what's going on here. We're going to design a graph, and we're going to determine if this relation is a function, all right? Can you handle that? My goodness, a lot of things there going on in this little problem. So, hey, everybody got the paper ready to go? Let's see what we're going to do. Got some graph paper here. First of all, this is one of those problems where a lot of times we see these x's and y's, we plot a bunch of points and say, well, those are worthless. What's that about? But in this case, it's going to be very important because what we're going to do, we're going to allow the x-axis to be, I'm going to put it out here, it's going to be our time. All right, it's going to be important to us. The y-axis up here is going to be how much money are we going to pay to park? Now, according to our problem setting, it says $7 is the maximum. I always wonder, do we have enough spaces here? Sometimes your graphing paper at home is probably, oh, we're right up there at 7. We are good. We're good to go. This one, yeah, we're going to be fine. We're going to get our hours all in here. So you say, well, Ernie, wait, whoa, what are we talking about here? All right, so let's take a little example here. Let's say we start off, all right? Start off at x. By the way, we're going to be in 0 all the way over here. Everything's positive, right? They don't pay you money. You pay money to them, all right, to park. So this is the money. This is the time. And everything's going to be in the positive. So all of our graph is going to be up here in quadrant 1. All right, that's the first thing. And remember, also the other question we want to know, is it going to be a function? Is it a function? Is it going to pass Curious George and the vertical line test is what we're going to be looking at. Then we'll see, and maybe call it something. I got your attention now, right? So we are going to go in there. Our time is at 0. We have found a parking place. We've gone to the thing. We have got our ticket. We are now officially in. There is no turning back. You say, well, Ernie, what if you go back in 1 minute? You have still paid $2 to have the experience, all right, of driving through the parking lot. If you can't find a place, you paid $2 to have the experience, all right, kind of thing. So, or if you don't like the place you were going to be assigned, you still paid the $2 for the experience. You're not going to be able to turn back. Now, keep going along with this. So once we've done that, we work along here, and our first hour, we're going to stay in there, and we stay, and then we get to this, and I'm exaggerating it, but that is that point where we have completed our first hour. We are now in there. And we didn't get back in time from doing our shopping or whatever it was. So all of a sudden, we are now at a higher rate. We've been in there 1 hour. We're now paying how much? You got it, $3. Now, yeah, we just went up by $1, right? So start off $2 across and see how this is working. Isn't that pretty cool? Go along a little more. Oh, you're good until, got detained or something there. Didn't get back, all right? Now you have gone up, your price has gone up another $1. You're starting your third hour actually being in there, but you're in the, if you've done 1 hour, you've done 2, now you're working on the third hour, so to speak. Second hour plus time, all right? And we're going to kick along over here until we come to, the end of that. We now have made 3 hours. Guess what? They're still charging you at another rate, okay? Because that's the way the computer works. And they don't pay much attention to you. I'm sorry, they don't. So keep kicking along. Here we go. How far are we going to go with this? Well, we said we max out at $7. All right. Now, where are we right now? 2. This is 3. This is the 4. This is the 5. So we got a couple more to run here. This is going to come back in. Here we go. And notice I'm shading these points in right there because that's where we're actually paying. This was, not going to pay that amount. We're going to have to jump up. All right. Is everybody good? And by the way, this works on your gigs for your phone. After you use a certain amount over a certain amount, you move up to the next level for a while, unless you're on the unlimited, which may happen here once we finally get up to the $7 maximum here. So you're going to be unlimited parking at that point. But you get the idea. So it's the same approach. And let's see, we have going across here, another wide open circle. And finally, we get to that $7 moment. And no turning back, it keeps going. And we could just keep going off the page. However long we're going to stay in that parking lot from there on, we are good. Now, what's happening? Does everybody see what I mean? This is our maximum, $7. Did we go over $7? No, we didn't. We call this thing, what we call is a step function. It's a step function. And notice I said function, because you're all going like, well, you gave it away. You said we were going to figure out if it's a function or not. Let's see what happens. Curious George, back in action. One more round here. He goes along here. Well, he is going to go along here. And he moves along. And there's an interesting point right here. Are there 2 points, folks, lining up vertically? No. This one is filled in. This one is open. So we have only 1 point there. So we're a function at this point. Play the game some more. Keep going, Curious. There we go. Open, closed right there. Still a function. Keep going on up. Still a function. Same story. Same story. One more story. And then from here on out, everything's fine. So, again, this is what we call a step function. And it's a big thing in our world. We see it quite a bit. Like I said, that's how you get your gigs and your pricing. Some of you say, well, I buy unlimited. Well, that's fine. You've got a maximum. You're flat out there, okay? But others of you say, well, what would it have been at 2 to 10 or 10 to 20 or 20? You know, you've got all these different levels, and then eventually, bam, it's unlimited. You don't pay extra after a certain point, or at least you hope you aren't. So that's what's going on there, all right? A nice practical application? Yes. Functions, we have them all over the place out there. We certainly do. And sometimes they come in that y equals mx plus b form, which we'll talk about in another session, all right? In the meantime, let me remind you that you can take us out on Facebook, and we'd love to remind you how to do that. There we go. Like us, love us. Above all, share us. Share what's going on with us. And also, we post these links that you missed the show, you can catch the link and go right to it from there. www.facebook.com/Mathline Online. And where you're going to see the show, you're going to see it on YouTube, and you subscribe to www.youtube.com/just Mathline there. But you got to subscribe, and then once you're in there, you can stream us. You can do all sorts of things. We are working to give you the convenience of Mathline anytime, any place you so desire. But we appreciate you because you tuned in today, no matter wherever you were, all that. We will tell you, it's summer school. We have done functions today. Do we function? Oh, yes, we can function. We are able to function, and we can do functions, and we know what a function looks like. How about all those good things? And we did hopefully put the fun into function today as you went and parked and tried to figure out, what's he talking about? Have a good rest of the day wherever you might be. And you know what? You know, we always tell you, but it's true. We will see you once again next time.
PBS Kids, making sure free educational programs are accessible to all children across America. From your PBS station, online, and on the go. Every child can watch their favorite high-quality PBS Kids shows for free, anytime, anywhere. Help give America's children a better chance for success. Support your local PBS station today.
Hello, I'm David Reynolds, President of Home Federal Bank. On behalf of East Tennessee PBS and Home Federal Bank, I am pleased to announce this year's Be More Award winners. Each month, Home Federal Bank and East Tennessee PBS present a Be More Award and recognize a leader or organization that provides important services and support to our community. Home Federal is proud of our long-standing commitment to supporting the people of our community, and it is an honor to bring to you these outstanding leaders and organizations.
My name is Faith, and I'm the founder of Faith and Friends Horse Rescue and Sanctuary. Faith and Friends is a certified 501c3, 100% volunteer-ran organization in Corrington, Tennessee. We specialize in taking in and helping the community with their equine and animals, mostly equine. We take an abused, slaughter-bound, owner surrender, and neglected equine. We are one of the few rescues in East Tennessee that takes in owner surrenders. We have a huge need. People, whether it's they're ill or they've gotten down on their luck or they've had a family death, we try to help people with their animals, and if they can no longer take care of them, we help them take care of them until we can get them into the rescue. The horses that we bring into the rescue are all rehabbed 100%, and either they go into our therapy program, or if they are not suitable for our therapy program, then we adopt them out to Loving Forever Homes. We believe in quality over quantity.
We are driven by our public service mission to provide opportunities for exploration for everyone. We are East Tennessee PBS.